Okay, so we're studying 10.1 and we are going to go ahead and hit play here, and I want you to take a look at this, and this here is what we call a parabola. Again, I want all of you to say parabola. Parabola! Parabola, not parabole, but parabola. And a parabola makes this arching sort of sound, path, and it kind of follows the same thing as a firework. And soon, and I'm going to go ahead here in just a second, but where that firework reaches its maximum value, that's actual a term, is a maximum value. We also have parabolas that go the other way, and we'll talk about those in just a second. All right, so today we're learning about quadratic functions. As you can see, we're going to graph quadratic functions. We're going to find equations for the axis of symmetry and figure out the coordinates of the vertex of the parabola. The vertex is your maximum value, where that firework explodes, or maybe if you're a scuba diver, as you're diving down your minimum value, or where you reach the bottom. So anyway, we'll talk more about that later. Again, the key concept is a quadratic function can be described by an equation of the form y equals ax squared plus bx plus c. I know that says equals, so let's just go ahead and fix that right now. I don't know why it says equals. Because some slacker made this, where a doesn't equal 0. And I want to save this right now. Okay, there we go. Where a does not equal 0. So a can't equal 0. We've done these problems already. We've actually worked with these in Chapter 9. We didn't even know we were working with quadratic functions because we never graphed them. Okay? You're going to be so mad at me once you realize what I put you through to factor, to find when we're solving those equations and how you had to factor them out. Now you're going to be really mad at me because you're going to, in a short while, you're going to learn the easy way of finding or solving those equations. But you're going to also find out what solving those equations really meant and what that meant when we solved it, when we equaled it to 0. You know how we factored, then we made it equal to 0? You're going to find out what that actually meant. It's kind of cool, too. So, and it relates directly with these parabola. Let's say it again, because it's such a fun word to say. Parabola. Parabola. All right. So, this is, again, this is taken directly from your book, and the Sky concert in Peoria, Illinois. All right. I know what song they probably play at that Sky concert. What do you think they play? Baby on fire. Whatever. I get a fool out of myself today. Anyway, the Sky concert in Peoria, Illinois is a 4th of July fireworks display set to music. If a rocket firework is launched with an initial velocity of 39.2 meters per second at a height of 1.6 or 1 6/10 meters above the ground, the equation h equals negative 4.9 t to the second power plus 39.2 plus 1.6 represents the rocket's height h in meters after t seconds. The rocket will explode at approximately the highest point. So, looking at this graph is this formula. What's something that you notice about this parabola? So the equation, again, is negative 4.9 t to the second power plus 39.2 t plus 1.6. What's one thing you notice? Yes?
Like on the graph, it's like it explodes at the top, and there's like a solid line going up.
Okay, good. And that's just saying that here's where it exploded, and then maybe the debris comes down, something like that. The rocket kept on going, it would go down. Good. What do you notice about the A value? Yeah, it's a negative. What do you think that negative does? Yeah.
Is it like how much it slows down?
Actually, not in this case. we'll see. We're going to figure out if A equals a negative value, we're going to figure out what that actually does to our graph. That's coming up here shortly, okay? But it does have a value. It does mean something. Okay, so here we could take and we could use a table of values to graph y equals 2x squared minus 4x minus 5. What do we notice about the a value in this one? Just real quick. Ben?
It's positive.
It's positive. What do you see as being the difference with the a value as a negative here and the a value is the other one? Sarah?
The top, the negative one is at the top of the graph, whereas when it's positive, it curves upward, and this one curves downward.
Yeah, and actually that's we're going to start to say that this points downward. This parabola points downward when it's negative, whereas this one where it's positive, this one points upwards. It opens upward. Okay? Good. And we could simply put in values here for x. Okay? And you're going to see exactly here in a second why they open upwards and why they open downwards. But think about this. If I put in to the value -2 into this, okay? So if I put in -2, let's move it down just for a second. I can graph it. I can graph any of these. I can't use graph though. So if I put 2, and then I'm going to put in parentheses, -2 squared minus 4 times -2 minus 5. I can, and then I can solve for this. -2 squared is what? -2 squared is what?
16.
Not negative.
16.
4.
4. -2 times -2 is?
4. Oh,
4.
okay, I thought, never mind.
So we've got 2. We've got 2 times 4, because -2 times -2 is 4. -4 times -2 is 8. So it's +8 and -5. So now I've got 8 here, because 2 times 4 is 8. 8 plus 8 is 16. And 16 minus 5 is 11. This one here, this one goes to 11. So the value for that, we can plug and chug. We can put those values into our table and or plug our x values into here, and we're going to get a y value. Okay? What's something that you notice about this? What's something that you notice about this parabola? Look at 4. Daniel.
Instead of going positive, it's negative.
Okay, good. It gets smaller and smaller, but then notice.
It gets big.
It gets larger and larger. So it comes down and it reaches this value, this minimum value, doesn't it? And then it begins to increase. It comes back up. Okay. So, but also there's something very special about this. Notice, look at 4 here. Look at 4. What do you notice about 4 when x equals 4?
Same line
It has the same y as what?
as -2.
As -2.
That's what it always is.
What else do you notice? What else do you notice? Come on, think mathematically. You guys can do this. What else do you notice? Noah.
It's a function.
It is a function. What makes it a function?
None of the x values are the same.
None of the x values are the same. You know it's really hard when you graph these and you really zoom out? This is going to look like a straight line. As it comes up more and more, it ends up looking like a straight line. But you have to know well enough that if you zoom in on it, it's not a straight line. It's actually gradually increasing, or kind of moving its way out to where it never touches. But yeah, it'll pass the vertical line test. Anything else that you notice? Jacob.
So all the Y's, if you look at them, it always goes down. But if you look on the opposite side of the scale, so if you go to like -2 and 4, and then -1 and 3, they all have the same Y.
-1 and 3. They have the same Y.
Yep. If you keep going down, they'll keep having
0 and 2 have the same Y. And notice this part. Do you think this is a special part? If I cut this right here, boy, I kind of do it with that white. Let's do it this way. Let's use a crayon. We don't use a crayon very much. What can you say about that right there? There's a mathematical term for it. They're symmetrical. Good. I'd be so frustrated if my pre-algebra students didn't know like we just studied symmetry. But yeah, this side is the same as this. Do you think, if we went to -3 and we found the Y value for -3, do you think there would be another, what Y do you think would be equal to -3? Or what other X value would have the same Y value? Well, let's do it real quick. Let's find -3. Livia. I'm going to pick on you. Livia. Let's do this. Okay. 2 times -3 squared. What's that equal?
9.
9. So 2 times 9 is
18.
18. Good. And then -4 times -3. What's that equal?
12.
12. And then -5. So that's 30 minus 5. So this equals 25. Can you tell me another X value that's going to equal 25? Brendan?
I'm gonna say 5.
You're going to say 5. No. Oh, yes. Why?
Well, I guessed that because 0 and 2 both have the Y value of -5. -1 and 3 both have the value of 1. And -2 and 4 both have the value of 5.
Yeah,
So
and
I figured the pattern is going on.
let's get our, let's use black here. So you're saying these two kind of work with each other, and these two kind of work with each other, and these two kind of work with each other. So you're saying since that's -3 and it's one less, that this one's going to be 1 greater. And you're absolutely right. You're absolutely right. And that goes on forever. And notice they've got the arrows here. That goes on forever. Continually goes up and up and up and up. Okay, this one points upward. If we continually graph this, it's going to go on forever, never, 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 never. Okay, point.
It's on the recording.
So, consider the standard form y equals ax squared plus bx plus c. Notice that the value of a in example 1 is positive, and the curve opens upward. The lowest point or minimum of the graph is located at 1, -7. So if A is a positive, our vertex is going to have a minimum. Okay, there's a minimum point that this graph is going to be, that it's going to have, and it's going to point upward. Whereas, like in our firework problem, when it's a negative, when A is a negative, it's going to reach a maximum value. Okay, and you don't have to have this memorized yet, but you will eventually. So start to put in your head. Think about the firework as being a negative. It's a negative thing. I don't know. We'll come up with some reminder. The firework bombs are negative. That's a bad thing. Same. All right. So moving on. Here, the value or the function y equals negative x squared plus 4x minus 1. Now we could plug and chug here, but it's already done for us. And I could make you do these, but if you did this, you notice that this one reaches a maximum. Right here, we've got a maximum value. And a negative a, here we've got a negative 1x squared, even though there's not an a there. That's not a 0, that's a negative 1x squared. Negative 1x squared gives us a value that reaches a maximum value. And also, this graph opens downward. So this one opens downward. So when it's a negative, just like Sarah said earlier, this one opens downward. Moving on. Okay, so let's, so noticing here noticing that when the a is a negative, it points downward. Let's move on. When we, as Samantha told us, that parabolas, I don't know what happened to our arrow here, so we better make one. When parabolas, all parabolas reach a point, it's either a maximum or minimum. Where that point where it reaches creates the line of symmetry. If you take that point, and soon we're going to learn that that's called the vertex of our parabola, that point, if we draw a straight line on the y, x equals a value, that is going to create our axis of symmetry. So it really divides our parabola in half. Okay, make sense? We'll learn how to graph these later on to show that. And we're going to learn just here. Well, we might not learn today, but we'll learn shortly how to graph that. Yes, sir.
You just like an arrow on the other side.
Oh, I see.
That's the one. That's the y-axis.
Oh, I see why it wasn't even the parabola. It was. I see where I'm at. Cool. Moving on. So this is the key point here. The key point. The equation of the axis of symmetry for the graph of y equals ax squared plus bx plus c, where a does not equal 0. Okay, to find the axis of symmetry, the line that cuts the parabola in half, we're going to use the equation negative b over 2a. Negative b over 2a. That you have to have memorized. That you're going to be tested on. Okay, you have to be able to come up with the line. So x is going to equal something. So if x equals something, that graphs. It's a what kind of graph? What kind of linear graph? When x equals something. Come on, turn on your heads here. When x, like if x equals 1, what kind of line is that going to be? Yes. No? No.
Perpendicular.
If x equals something, no matter what x equals, it's going to be a vertical line.
Oh yeah, the vertical line.
Okay? It's going to be a vertical line. What slope does that line have? 10.
Undefined.
Thank you. Undefined slope. Vertical lines have undefined slope. Okay? If it's a horizontal line, it would have a slope of 0, but a vertical line, we can't, it's undefined. Okay? So if you're taking notes, this is something you're going to want to put down. X equals negative b over 2a. So considering the graph, y equals negative 3x squared minus 6 plus 4. We can write this equation in y where b, negative b over 2a. So I know it's done here for us, but I want to show you just for a second. Let's put this on here. So if we take negative b, and I'm going to do it over here, Have to work in white again. So if we take x equals negative b over 2a, we know that from what we were doing before that in this case a is negative 3 and b is negative 6. That's what it's the same thing as we were working with when we were multiplying to AC and adding to B. It's the same thing. A, B, and C are still the same. So I'm going to take and put negative 6. Okay, it's always negative B over 2A. So negative 6 over 2 times negative 3. Okay. So negative 6 over 2 times negative 3, so that's negative 6 over negative 6. Negative 6 divided by negative 6 equals 1. So it's negative 1. That's a positive 1, but this negative out here changes it. Okay? So our axis of symmetry, in this case, is negative 1. Someone made the silence that or
Sounds
something.
like someone's like charging their phone.
Yeah,
Charging.
that's what it does sound like. Okay. So again, in the book here, it'll go through this equation and it'll show it to you. Soon you'll be working on your own. The second thing that we can do with our graph is we can find the coordinates. So since the equation of the axis of symmetry, x equals negative 1, and the vertex lies on the axis, the x-coordinate for the vertex is negative 1. So we know that the lowest point, the x is going to equal negative 1. Okay. So if we put that into our equation, where x equals negative 1, we can put x, negative 1, into the whole equation and solve for y. And that's going to give us our vertex. So in this case, our vertex of this equation is negative 1 and 7. Is that going to reach a minimum or a maximum value? This is going back into the beginning of the lesson. Is this going to be a minimum or a maximum value?
Oh, it's gonna be a maximum.
A maximum? Or minimum? Hey, I got 2 answers there. Think back to our firework problem. It went like this, right? And then our other graph went like this. Is this more of the firework or
It's more firework
why?
because it opens up to
Negative.
the negative.
What is negative?
The first one's
A is negative. A is negative. So this problem is going to have a maximum value, and this maximum value is going to be at negative 1, 7. Okay? That's what the vertex is, and we're going to do this more soon. Actually, it's going to be more tomorrow, but we're going to do this more tomorrow. So again, the third thing that we can do with that graph right now is we can identify the vertex as being a maximum or minimum, and I already put you guys through that one. Okay? If A in this case, if A is positive, the vertex is a minimum. Okay, and then it's just the opposite. If A is a negative, the vertex is a minimum. Maximum, excuse me. Okay. And that means that this one, if it has a minimum, it opens upward. And A maximum opens downward. Cool?
Yeah.
No, I say cool, you say eel. Cool?
Eel.
Coolio. Cool?
Eel.
I don't know, I've never done that one before. I don't know if that works just right. Okay. So with that, really? This is worse than my 10-year-old son.
Here, toss it over.
I'm going to skip this one right here.
There's no plan, toss it over. He's keeping it.
And do we have enough time?
No.
Yeah, I think I'm going to pause there. Yes, sir. Hold on one second.
Toss it over.